Hello, and welcome to Penn State Berks Phil 10 Critical Thinking. This is Lecture 3. We'll talk about compound propositions, fallacies, and conditionals. Now, we've already been over the distinction, at least basically, between arguing and quarreling. So remember, an argument consists of two or more premises that infer some proposition that we're intending to be true as a conclusion. So if you recall, propositions themselves are either true or false, and then the argument's going to be either valid or invalid, and sound or unsound depending on the truth of each proposition. So an argument with a false proposition, even as a conclusion, can still be arrived at in a way we would say is valid but not sound. We could get then to a valid argument which would have true propositions where the conclusion would logically follow, and we'd call that both valid and a sound argument. Now, logic, too, if you remember, is not about determining if a proposition itself is true or false. It's not in the nature of fact-finding. What it deals with is the relation between the truth and falsity of propositions. In this lecture, we're going to look at that along the relation between what we call compound propositions. Now, compound propositions are just what they sound like. In other words, there's two or more propositions put into a single statement with some sort of connector. So to say, Tammy let go of the balloon is a simple proposition. To say, Tammy let go of the balloon and it is rising up into the sky is a compound proposition. What we're going to look at is the truth and the falsity of those connectors, which could be non, we'll see that in a second, or that's an operative, or the terms and, or then, which are connectives. But before we do that, let's quick swing back to the first two laws, or we would say principles of logic. Now, oftentimes they're listed as three. The second one here, truth value, where we're simply saying that a thing is assigned a particular value, and it can't be both those things. So this will be true or it will be false. So think of value here not in terms of just like some sort of like sentiment that we're placing on it, like what we value, but think in terms of like in mathematics, say, the value of x, that type of thing. So we're assigning not both, but just one truth value. Now, this first principle that we talked about, bivalence, this is just, it's a semantic notion where the apple is red or it is not red. So there's no negation of a connective between the two. Now that's going to be eerily similar to what we're going to look at today, which is known as the excluded middle. And I'm going to explain just very briefly what the difference is between those. Because in this course where we're more concerned with critical thinking, we're going to be really keen to have some way to identify how to use this. It's good for you to know that there's a distinction between bivalence and excluded middle. It's more important to you know how to use it when you see it out and about, say in the news or in media and such. So let's look at logical negation, and we'll look at the functional operator as non. And to do this, we'll look at the third principle, which is the principle of non-contradiction. Now, I start to use some symbols here just because it's in all likelihood something that you're going to see in a particular text. So that little sideways L is a negation of whatever that is. So here we'd say, P is not P. That's all that pretty much means. To say what is the principle of non-contradiction, I'll give you this phrase and then I'll put it into a sentence. And it's much easier to see in the sentence, and it's going to be something you'll identify with pretty quickly. So the law of non-contradiction means that P cannot be and not be in the same way at the same time. So if somebody were to say, is that apple ripe? The apple cannot be both ripe and unripe. If you asked somebody if that apple was ripe and they said, well, it is both ripe and unripe, at that moment you know that's impossible. It has broken some sort of rule, even if you couldn't name it before. But now you can say that's the principle of non-contradiction because the apple cannot be both ripe and unripe in the same way at the same time. I want to show it to you in this diagram that's known as the square of opposition. And you see on the top left, all S is P, then the right, no S is P, some S is P, and some S is not P. Now, you remember that the all, the no, and the some, these are the qualifiers of a particular proposition, and all S is P, remember, that's the proposition. And then the is or the is not, or the are not, depending on how you're saying it, are the copulates that connect it. So The S is the subject and the P is the predicate. So we can say all apples are ripe. That would be an A proposition. Now, let's look and see how then this non-contradiction principle fits into this. If we are going to say that all the apples are ripe, and we say that some of the apples are not ripe, both of those cannot be true. It's impossible. Either they're all ripe or they're not all ripe. So the minute you say some are not ripe, then you have negated basically the fact that they all could be. So we would say that these two things are contradictories. So the all S is P is a contradictory statement to some S is not P. Now, again, don't get overly concerned with looking at and trying to absorb the square of opposition. It's enough that you know that an apple or anything cannot be and not be in the same way, in the same time, two different things. It's by the principle of non-contradiction. Now, the law of excluded middle, here what you see is something that looks, at least may sound as I start speaking, very close to the principle of bivalence. All right? All we're seeing here in the symbols is it's not P or not P. In other words, it has to be one of those different things, okay? So P is either true or P is false, but it's not both. Now, the difference between this, real quickly, the excluded middle and bivalence, is where we said that bivalence is more semantic. This is more syntactical, so it has more to do with the structure of how the argument is being formed. Again, when you put this into a sentence, hopefully it's a little easier to understand. Elvis is either dead or alive. Those are your two choices. There's nothing there in the middle, okay? If we're going to see this on the square of opposition, we would say that, either all that which is Elvis is alive, or no, that which is Elvis is alive. One of those two things are going to be true. These are contraries, we would at least say, using the square of opposition. So this covers logical negation and the functional operator of non. What we're going to look at on this slide and then on the next are known as either conjunctions or disjunctions. A logical conjunction, rather than the non, being placed in front of something, is the logical conjunction of and. So a logical conjunction is true only and if only both conjuncts are true. Now, this is, again, quite easy to put together. So if we have two propositions, the first one labeled P, the apple is ripe, and the second proposition labeled Q, Elvis is alive. Now, the minute we connect those with the conjunct and, both of those things have to be true for that entire compound proposition to be true. If both of those aren't true, then, or even if one of them is not true, then it's false. Now, I don't really want to utilize truth tables throughout this course, but this one makes the point, I think, quite easily, and it's not very hard to digest. In the first column, we have the proposition P, the apple is ripe. In the second column, we have the proposition Q, Elvis is alive. Now, those are simple propositions, and each of those simple propositions can either be true or false, right? That's the only choice that we have. But when we combine them with the logical conjunction and we say P and Q, the apple is ripe and Elvis is alive, together they can only be true if both the propositions are true themselves. All right? So if we were to say the apple is ripe and Elvis is dead, that first, let's say, row where it's true, true, true would be what we would say that fits. So it's true. That apple looks ripe, and we know that Elvis is dead, unless we buy into some conspiratorial theory. But if we leave it as is, and we say the apple is ripe and Elvis is alive, you see we have true as far as the proposition P goes. The apple is ripe, we'll say. But the proposition Q, Elvis is not alive, that's false. So together, because they both have to stand together and not apart, the overall compound proposition is false. Okay. Now, you've probably heard this one fallacy more than once, at least in some form. It's an informal fallacy because it doesn't really deal with the structure of the argument as much. And this is known as the fallacy of a complex question. So what it is doing, it's giving it's giving the idea that there are two various propositions put into a compound proposition that are brought together by the logical conjunction and. But it's really not. It's almost something that there's something about it that sounds true when you first hear it, but we also know that there's something wrong with it. For instance, if somebody were to say to you, "Are you going to start being nice to me?" Well, you want to say yes because you want to be nice. And the minute you do, they're going to say, "Oh, so then you admit that you have not been nice to me." So it gives the impression that there are two full propositions and that you can basically answer one without the other, but it's put into a complex question into one statement that is a fallacy and is a rhetorical device just basically to trap somebody and say, "Ha, gotcha." So you could probably think of how many ways that you might have heard over the years somebody putting a complex question together and we're not quite sure know how to answer. Do you walk to school or carry your lunch? That type of thing. I remember when I was young, that was one that came up often. All right. So the other type of logical disjunction we'll say here, instead of using and, uses or. Now, once you use or, they're not both together. So they're can be thought of separately, and they can be thought of separately either as inclusive, or they can be thought of separately as something that is exclusive. So what we will say in the first regard, that it is an inclusive logical disjunction and is only false if both the disjuncts are false. All right, so both of the propositions that are in there. Let me give you an example. Somebody might say to you, you need a BA or the equivalent experience to apply. Okay, now rather than and, only one of those things are necessary for you to apply. This is inclusive because if you have the first one, say if you have a BA, you don't need the second one. If you have the second one, you don't need the first one. So this is an inclusive, what we'd call P, and that V is the logic symbol for or. This is P or Q. And it's only false if both of them are false. All right, so you cannot apply if you have neither a BA nor the equivalent experience. With this exclusive logical disjunct, it's true if no more than one disjunct is true. So this would be, you can come home now or be grounded for a week. So we see here that the or now, it's going to be one or the other. In other words, with the inclusive, you could have both a BA and the equivalent experience. You only need one, but you could have them both. With the exclusive logical disjunct, you can come home now or be grounded for a week. You're not going to get them both. As a matter of fact, if your parents said that when you were younger and you came home now, you did it so you weren't being grounded for a week. Okay, so there's the difference between these two is only in the exclusive. It's only going to be true as an overall statement if no more than one of the disjuncts is true. But the inclusive, it's only going to be false if both of them are false. Now, there are fallacies that pop up with this. I'll give you two. The first one is affirming the disjunct. So if we say the sidewalk is wet, either the sprinkler is on or it rained. Now, the last part of it is, the Q is it rained, and the P is the sprinkler is on. So let me read it in full sentence because I put it into some symbolic language there at the end, so it just would fit on the side. We'll say the sidewalk is wet. Either the sprinkler is on or it rained. Well, it rained, so therefore the sprinkler must not be on. Now, we really can't say that, can we? Because if somebody said to you the sidewalk's wet, and you say, well, either it rained or the sprinkler's on, and you said, well, it rained, so it can't be the sprinkler. It could have been both. I've been on campuses where sprinklers were running even when it was raining, or they ran and then it rained. So just because you affirm the disjunct doesn't mean that the other one isn't true too. There's probably a lot of, say, political statements and such that you can read into where somebody is trying to, because they affirm one, they negate the other, which is what that little sideways L is, remember? So just because one is affirmed doesn't negate the other, they both can be true. So we would call that a formal fallacy. And the difference here is because there's a defect with the structure of this, and this can only be deductive argument, okay? The problem, really, is that it just assumes that the other is false. But as we know, and I already stated, one, they both can be false or they both can be true. The other fallacy I want to bring up is what's known as the false dilemma. You know, in other words, you're giving people options per se, but you're almost pitting one against the other, not giving them a clean choice. Let me explain. So, if somebody were to say either you vote or you don't love your country, now this again is an informal fallacy, but the problem here is that it assumes that either they are exclusive. In other words, there are people who do not vote on principle, and they love their country so much that they refuse to vote for any candidate on that very principle. So they're not exclusive. But we also don't know if this is exhaustive. We don't know if there's other things that fall into here. So how often would somebody say, either you do this for me now or you don't love me? The minute that somebody is put into some sort of dichotomy like that, and this is often called the false dichotomy, that individual, because it's combined with the or, right, the logical disjunct, it almost appears as if it's you have to choose one of those. But you're asking me to choose one when I already do those both. In other words, I will not do that for you, but I do love you. I do love my country, but I'm not going to vote on principle. All right. So when you go and search or, say on the internet and you're looking at social media memes or posts or political statements and such or advertising, it's probably not too hard to find somebody who's affirming the disjunct or somebody who's presenting a false dichotomy. All right, the last relation of truth and falsity we're looking at is a functional conditional known as then. So this is the if-then rather than the either-or. Now, we often see these show up when people are making predictions or you're placing bets or you're promising something to somebody, causal relation and such, right? We can work these with an antecedent. So that arrow is, we'll say, is, therefore. So P therefore Q, or Q therefore P. Probably not to say there, but we'll leave it at that. Now, the antecedent is always false when the antecedent is true. Oh, I'm sorry. The functional conditional P therefore Q is always false when the antecedent P is true. So we're going to put these into sentences. And the consequent Q is false, otherwise the entire sentence is true. So here's a way to look at this. And it's always easier, again, to hear it in a full sentence. If you are a citizen of the U.S., then vote regularly. So what we would say here is that if P, you're a citizen of the U.S., if that's true, then voting regularly, Q, is false or true, otherwise it is false. If this becomes the condition of the truth or falsity of that compound statement, then what we are saying is, if you are a citizen of the country, if that's true and you don't vote regularly, that's false, then the entire compound sentence or proposition is false. In other words, it's saying that you don't. It's basically just trying to find the relation between what comes before and what comes after. Now, the consequent would be, if you are a citizen of PA, then you are a citizen of the U.S. So, if you are a citizen of a PA, true, and then you are a citizen of the U.S., true, then this entire sentence will be true. Now, sometimes it's an easier way to understand that there are sufficient and what we call necessary conditions that make these things basically understand to be the truth or falsity of the proposition. So a sufficient condition would be P is sufficient for Q to occur. In other words, once you're a citizen of Pennsylvania, then we already know that you're going to be a citizen of the United States, because being a citizen of Pennsylvania is a sufficient condition for the event being a citizen of the U.S. to occur. A necessary condition would be, if we were to wrap that sentence around a little bit and say, if you're a citizen of the U.S., then you are a citizen of Pennsylvania, there's something there that's not necessary. For P is necessary for Q to occur. So just because you're a citizen of the U.S. does not mean that you are a citizen of Pennsylvania. In other words, that is not a necessary condition, because you could literally be a citizen of another state. All right. So what we did here is we basically, in a real brief overview, looked at the relations of truth and falsity, logical negations, logical conjunctions and disjunctions, and functional conditionals. What I'm hoping that this does, if it sounded confusing the way that it was worded, that it's an augment to the reading, which is more than what I intended for this, rather than this to be a standalone lecture. If I were to work this out where I can give plenty of examples and such, we would be looking at, a 2-hour video. But this is something at least that's going to help you before you do the reading, and then when you meet in class, we'll be able to talk it over and iron out any of the confusion that there might be between these. Thank you very much for listening.